Come on. So last class we discussed two things. Thrust we have discussed, perpendicular force acting. Pressure we have discussed, perpendicular force upon the area. Some of the questions that they may ask you is that they may give you a question like this, that the same force is acting on this surface, same force is acting on this surface. Is the pressure same? No, the pressure is not same because the areas are different. This is a bigger area, so the pressure will be less. That's a smaller area, pressure will be more. Then we also spoke about pressure in fluids. Okay, every fluid exerts pressure, and we'll be talking more about water. And fluids exert pressure in all direction. Best example is अगर पानी का पाइप, म्युनिसिपैलिटी वाटर पाइप फट जाता है, जिधर भी फटेगा वहीं से निकलता है ना. It's not that it will go out only. And say suppose you take one syringe and suppose you can do on a water pipe tick 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 one circular hole, so water will come out equally in all sides. So fluids exert pressure in all direction. Today what we will study is most interesting, how things float. I gave you one idea that in order to float, object which floats, its density should be less than the density of the fluid on which you are floating. The best example was that I said that, you know, something like an elaichi will float over condensed milk. That's because elaichi's density is less than the condensed milk density. So the elaichi floats on it, right? We go ahead from there. Any doubt till here? अगर यहाँ तक कोई doubt है तो आप समझेंगे नहीं आगे. Clear so far? Right, fine. Chalo. So now we take our discussion further into pressure in fluids. And I told you one more thing. Pressure increases with depth, which I told you it is rho gh. Okay, na? Rho gh. And if suppose rho gh formula, what they have done? They have cut this chapter into bits and pieces where they have eliminated some portion. So either you accept it as a story or you understand from basics. I would always say understand from basics. Say for example, how do you understand that pressure down will be rho gh? Just simple example. Let us say, let us say that you have liquid inside a vessel. Now from here you need deep understanding, okay? Liquid inside a vessel. Take out a cubical column of liquid. Imagine a portion of liquid which is cuboidal in shape. Ice cream है, freeze कर दिया, एक cuboid काट के निकाल रहे हैं. That's called a liquid column. What do we call it? Liquid column. Just like the air above our head, we call it air column. This is called liquid column. How does that rho gh come? Very easy. Just see. Let's say this is my liquid column. It's cuboidal in shape. Just समझ लो. Got it? This is cuboidal in shape. This is a liquid column. Imaginary. Inside a liquid, a cubical column. This portion is A. Do you agree? Cross-sectional area. And what is this height? This height is h. Agreed? Let us say this is a liquid. So this liquid must have some density which is rho. This is the density. Now our question is, this liquid column, let's say we have put a person out here floating. The person feels a pressure on him. Why? Because there is a liquid column above him. है ना, उसके ऊपर पानी है इसलिए तो वो प्रेशर फील कर रहा है. ये वही पानी है हमने बाहर निकाला है. आपको आसान समझने के लिए क्यूबॉइडल लिया है. You may say, sir, why did you take cuboidal? You take cylindrical, your choice. I have taken cuboidal. Understood? Suppose समझ में आ रहा है ना? This is above this person. Now, this whole fellow will have a weight downwards. वही तो उसके ऊपर आ रहा है ना, उस इंसान के ऊपर लग रहा है. That weight is coming on this person. Imagine. What is weight equal to? Mass into acceleration. The acceleration for weight will be acceleration due to gravity. Okay. How do you connect mass? Density is equal to mass per unit volume. Have you understood? Density is equal to mass per unit volume. So what should be your weight equal to? Just tell me. The weight should be equal to rho times V into G. See? Mass is equal to rho into volume. Agreed? And weight is nothing but force. Weight is a force. Now can I write this as volume? What is volume of an object? A into how many A's? H A's. So can I not write it as AHG? Yeah. These are like A4 sheet papers. A. How many A's? Any volume is cross-sectional area into height. What is the volume of this pen? Say till here. Cross-sectional area into the length. Khira, up to this much. That is the volume. ठीक है ना? And what is pressure's definition? Pressure is equal to फोर्स अपॉन एरिया, एरिया ले ये कट गया, रो जी एच यहीं से आता है। ये सीबीएसई एनसीईआरटी ने ये सब नहीं पढ़ाता है। सो इफ आई टोल्ड यू द अदर डे प्रेशर इज ऑलवेज रो जी एच, व्हाट डू यू गेट फ्रॉम इट? द डीपर यू गो द प्रेशर इज हायर। दैट्स व्हाई आप टाइटैनिक नहीं जा सकते हैं, टाइटैनिक में प्रेशर बहुत ज्यादा है, यू विल ब्लस्ट आउट बाय द टाइम यू रीच टाइटैनिक। What did we infer from? Nobody is going to ask you this derivation. You infer one thing, जितना नीचे जाओगे प्रेशर इंक्रीज करेगा। What is the relation of pressure? Rho gh, rho into g into h. And where does h start from? Suppose I have filled this liquid till here, the h starts counting from here, जितना नीचे हम जाएंगे। So imagine this is श्रेयस श्रीवास्तव, उसको यहाँ पे रखेंगे तो प्रेशर कम आएगा, यहाँ पे ले जाएंगे और ज्यादा, यहां पे ले जाएंगे और ज्यादा, यहां ले जाएंगे और ज्यादा। Now this is the pressure only due to the liquid column, but he is on earth and earth has got something called atmosphere also. Aparna comfortable or else just rotate a bit like this, then you'll be able to give your right hand. ठीक है, जगह है तो comfortable ना बेटा? I'm very sorry, I went off my head to order that table. ठीक है, so it is from this portion, but this person is actually on earth, so atmospheric pressure is also acting. There is one more pressure acting till here. This is what you'll read in class 11. Atmospheric pressure is acting on everyone, plus तू पानी के नीचे गया है तो पानी भी तेरे ऊपर दबाएगा ना। अभी कॉन्सेप्ट समझ में आ रहा है? जितना नीचे उतना ज्यादा प्रेशर। सबको ये चीज समझ में आया? The deeper you go, the pressure is more on you, and you not only face the pressure only due to this, you're also facing the atmospheric pressure, and we all face it. Everyone has atmospheric pressure on his head, whether you are submerged or not. Is this much clear? Right, this was only to make you understand that how rho gh comes. Now next part, let's see and understand a little bit about buoyancy, then we'll understand how objects float or what happens or doesn't happen. Now relate this thing. Take a small Coca-Cola ka khali bottle and take one bucket of water. Try to submerge the bottle. As you submerge, you always feel the bottle is coming up. That means some Atma, Pretatma is there in that fluid, which is actually pushing you upwards. It pushes you upwards. है ना? वानिया इधर कहाँ खो गए? ठीक है? So as you immerse anything partially or fully, you'll always feel that the thing comes to come up. The thing tends to come up. So there is a force which is acting on anything from the downward side, right? In plain language, that itself is called buoyant force. So if somebody asks us, what is buoyant force? If an object is immersed in water or any fluid, partially or fully, the object experiences an upthrust. Upthrust, we know what is thrust? Normal force. परपेंडिकुलर फोर्स, दिस फोर्स इज ऊपर की डायरेक्शन में, तो हम इसको बोलते हैं इट एक्सपीरियंसेस एन अपथ्रस्ट, एंड दैट अपथ्रस्ट इज नोन एज buoyant force, and this phenomenon is known as buoyancy. Does it happen for every fluid? Yes, it happens for every fluid. Buoyancy, इसको पहले समझिए। Let's say we have a vessel, and one of the best example is, let's fill it up till here, and let's say we take a cork and we have half submerged the cork and we are trying to put a pressure force on the cork, जाना नीचे जा ऐसे करके, we always feel that some force is being experienced by this cork to come up. That force is known as buoyant force. Simple. But next sections will not be that simple as this is. But you just understand what is buoyancy. Buoyancy is the phenomenon due to which an object, when immersed wholly or partially in any fluid, experiences an upthrust. The upthrust force is known as buoyant force. ठीक? The upthrust force is known as buoyant force and the phenomenon is known as buoyancy. लिखना चाहते तो लिख सकते हैं, लिखिए ना अपने लैंग्वेज में। Buoyancy, you can write buoyancy. When an object is immersed in a fluid wholly or partially. First try to, have you understood what is buoyancy? ऐसे हाथ नीचे लगाते तो पक करके बाहर आता है ना, वही buoyancy है। when an object is immersed in a fluid, wholly or partially, it experiences an upthrust. ब्रैकेट में लिखिए upward force. Upthrust means upward force. Or if you want to better it, write perpendicularly upward force. Clear हो जाओ पूरा, ठीक है? This phenomenon is known as buoyancy. This phenomenon is known as buoyancy. And the upward force or the upthrust is known as buoyant force. Sanvi madam, so upward force or the upthrust is known as buoyant force. See, this is the thing. See, again look at the figure. If this object is immersed in a fluid, wholly or partially, it will experience an upward force or an upthrust or a perpendicular force. That phenomenon is known as buoyancy, and this force is known as buoyant force. Yes.
Will this happen in
Buoyant.
Will this happen in fluids of different kinds of density?
Any fluid it will happen. However, right now, since we talk about sinking flotation, we'll be talking more about water and liquids. But this is there also for water also. Sanvi, did you understand this much?
So does it happen on air?
Yes, fluid. I said fluid. Air is a fluid. It will happen on air also. But in that case, we call it drag and upward. Buoyant force due to air drag, we call it. Okay. Don't you see that if you do skydiving and the person comes out, doesn't the person feel an upward force? Air resistance. Okay. Is this much clear? Up to buoyant force?
If we have a small gap in the object, it will still go down, it will also come up.
This has nothing to go down is secondary. Whether even if you go down, you will experience that force. In that case, your weight is more, that's why you are going down. आप डूबो, मरो, नीचे जाओ, Titanic, floating, whatever, buoyant force is always there. See, you and me, let's do an arm wrestling. Okay, you may win, I may win, that's a different thing. But forces are exerted by both of us. So right now we are trying to understand force exerted by me. Whether that is a winning force or not, we don't know. But I will be exerting a force on you. Net force may be working in your direction. That's why you are able to defeat me. So what you are asking now, drowning or baad mein, theek hai? So tell me one thing. Have you understood the meaning of buoyancy and buoyant force? Buoyant force. Couple of keywords in buoyancy there should be an object. Keywords. There should be a fluid. More we are talking about any liquid. And as human beings, we are interested always water, because we either do adventure sports in water or we get killed in water. So water is more of our interest. Okay, fluid, liquid. Then there should be a case of submerge. That can be wholly. मैं होने से ऐसे पढ़ता हूँ, wholly और partially. ये भी होएगा. फिर क्या आएगा? एक upthrust आएगा. और यहाँ से बस ये दोनों में ये keywords है. Next time when you talk about buoyancy or buoyant force, always ask yourself, are you able to relate these things or not? There should be an object, there should be a fluid. On that fluid, I will be immersing that object wholly or partially. Object will be feeling an upward thrust. Upward thrust is known as buoyancy. Bolo, easy हुआ कि नहीं define करना? Hot words. Your brain, as you are growing into teenage में और बढ़ रहे हो ना, your logical ability will increase, your mugging up capacity will come down. A kiddo will mug up faster than you without understanding, but your understanding level is going up now. So try to write it. कितना याद करोगे? ये याद करोगे या Rowlett Act याद करोगे? कितना याद करोगे? याद नहीं हो सकता, समझो, ठीक है? क्लियर इतना? अब एक बात बोलो, छोटी छोटी बातें करेंगे. ये है एक शिप, ठीक है? ये है उसी पानी में तैरता हुआ शौर्य, ठीक है? ये लोग सब क्यों तैर रहे हैं? डेंसिटी को मारो गोली, सब लेवल नीचे लेवल से सही है. ये क्यों तैर रहा है, ठीक है ना? ये शिप कैसा है? ये शिप ऐसा रहता है, देखो, द शिप इज ऑलवेज पार्शियली सबमर्ज्ड इन वाटर. डू यू एग्री और नॉट? ये आदमी भी कैसा रहता है? When you always swim, do you know what is the technique to swim? Like theoretically, if you ask me, I have learned theory swimming very nice. Your hand should be like this. and your mouth should be up always. This, then this. This is the water level. Mouth up. Mouth नीचे गया तुम नीचे चले जाएगा. Funda. Everything is physics. Whatever you do crocodile, whatever it is, pulling the water, but your hand should be on level with the water. This should be up. The moment this goes down, you will go down. Whoever has swum must have experienced it. ये ऊपर रहना चाहिए, ये ऊपर रहना चाहिए, आप ऊपर रहेंगे, ठीक है? So whether it is Shaurya or this, ये सब लोग partially submerged है. क्या ये story नहीं हो रहा है? And then they are not going down. अभी इसके ऊपर एकदम कार्गो है हांगकांग से, P&O नेडलॉयड में ये सब लिखा हुआ है, सब कार्गो लेके जा रहे हैं. यहाँ पे अभी हेलीकॉप्टर पठान शूटिंग होगा, ठीक है, ऐसा शूटिंग हो रहा है. डूब नहीं रहा है. इसका मतलब सम आत्मा प्रेतात्मा शुड बी देयर व्हिच इज गिविंग एन अपवर्ड फोर्स टू इट, है ना? बॉइंट फोर्स है. समझ में आ रहा है कहाँ स्टोरी लिंक हो रहा है? वहीं डूब जाता था. इसके पास वेट का अभाव है क्या? कितना वेट लेके ये जा रहा है? और यहाँ एक बॉइंट फोर्स को हम यू से डिनोट करते हैं हायर क्लास में, आप एफ भी लिख सकते हो. तो व्हाट इज द लड़ाई नाउ? द लड़ाई इज दिस वर्सेस दिस. और अगर जहाज को तैरना है तो इसको जीतना है, सिंपल. जब ये जीत गया, एंड देन द टाइटैनिक वेंट डाउन द वाटर. हाँ, submerged wholly also. We'll see that. No, submerged wholly means there are two things. We'll go to that. Now we'll come to that story. Very good. You have pointed out. Have you understood this much where the movie is going now? So we understood buoyant force. Now whenever we put something, our idea is to understand flotation and sinking. Our next topic to understand is flotation and sinking. पहला टॉपिक समझ लेते हैं. डेफिनेशन तो कोई भी चार्ट लेगा किताब से, पहले समझो फ्लोटेशन एंड सिंकिंग. फ्लोटेशन समझेंगे तो सिंकिंग. तो ये सब फ्लोटिंग है ना, ये सब फ्लोटिंग है. फ्लोट कर रहा है तो इसका मतलब कोई तो तुमको बचा रहा है. Somebody is giving you a force. Do you understand? That force is known as buoyant force, U. And so the game will be all between W and U. Vivan, you have gone for deep sea diving. Okay? So you should see it with more interest. W and U. And you are a human being. Think that you are a propelled engine or something. So the game is between. Is this much understood? Game is between this. Now let's see the game now properly. चलो अब game देखते हैं. 3 सिनारियो में गेम को देखेंगे. Scenario number 1. Observe the drawing very nicely. Okay. This is liquid. We have fully immersed an object in water. पूरा immerse कर दिया है. This is the case of sinking. ये नीचे जा रहा है. Let us see what are the forces actually acting on this body. What are the forces acting? There will always be a downward force due to its weight W. पृथ्वी बुला रहा है ना, आओ मेरे पास. And there is a force on this side, buoyant force U. धीरे धीरे देखेंगे buoyant. एक buoyant force तो रहेगा. We know, we have learned that object immersed, submerged, wholly or partially has a buoyant force. You tell me, when something is going down, who is winning the battle here? Weight is winning the battle. आप ये बोल सकते हो W is greater than U. Can you tell me that?
Yes.
Nothing stops you from saying this, right? So W is greater than U means that on this side, this is W, this was coming this way, and then our buoyant force tried to match up to it. इतना जाने के बाद और buoyant force नहीं है. So this is the excess W. समझ में आ रहा है कि नहीं? We had a W. The match was between W versus buoyant force U. ये देख, it's just like arm twisting. First of all, when the match starts, both of us are same. Then W starts increasing. My arm is going this side. ठीक है? That means he is exerting 50 Newton on my wrist. I am not exerting 0. I am exerting 45 Newton. I am not able to give that extra 5 Newton. So what is the net force working on my arm? 5 Newton, not 50 Newton. 5 Newton. तो ये इतना तक W ने उसको दबाया, U इतना तक दबाया. So there is a small portion left which is W minus U. W is greater. Is this thing not known as the net force? Is a net force? So now I can imagine that my block which was underwater now has got a net force in it. Net force. And that net force is W minus U. Considering the arm twisting example. U could not match W. There's some delta. Imagine that that is that 5 Newton extra. समझ में आ रहा है यहाँ तक? Now take Newton's first law. Whenever there is a net force, there is a acceleration. That's why James Cameron says, and then she breaks into two, and then the front bow, the bow goes inside, cracks, and Titanic's hull goes on the other side. And once you go down, you have a net force, you have acceleration, you'll go rapidly down. It is not a uniform motion. Physics is beautiful. This object now experiences a net force downward, and once here is a net force means acceleration. It will go rapidly down. Observe the making of Titanic documentary once again, and or the movie Titanic starts with one elderly lady taking on an helicopter. Have you all seen Titanic or not? So will be shifted from a helicopter, and they will all listen to her story. And then the director starts telling, she hits an iceberg, cracks, and then splits into two. And first the bow goes down, and once it goes down, it will go very fast. Net force. समझ में आया? अब एक बात करते हैं. Whenever an object is submerged, say suppose you are submerged halfway. Now we should understand also, sir, how do you calculate buoyant force? End of the day, we should be able to calculate buoyant force. ये प्रेतात्मा बोलने से तो नहीं होगा, इसका कोई value तो होना पड़ेगा. What is buoyant force? This much portion is submerged. Don't you think this much portion will also displace a volume of liquid? What do I mean by this? Put my hand inside a bucket full of water, and the bucket is completely filled. If my hand goes inside, the water will gush out. How much water came out is equal to what was the volume of my hand. समझने में मुश्किल हो रहा है तो और आसान करो. Okay, do you know what is the volume of a cylinder? What is the volume of a cylinder? Formula? Pi r square h. What is the volume of a आलू?
पानी उसमें डाल दो.
Sir, I don't know. आलू does not have any shape. तो आलू का वॉल्यूम कैसे देखेंगे? Take a measuring cylinder. These things are good in IGCSE. Take a measuring cylinder. In a lab, you get a measuring cylinder. इसको 50 सेंटीमीटर क्यूब तक पानी से भर दो. And bring your favorite आलू from रत्नादीप. आलू डाल दिया. आलू डालते ही ये पानी ऊपर चला जाएगा. Say suppose it climbed up to 80 centimeter cube. Can you tell me what is alu's volume? 30 centimeter cube. Very nice. So this much portion, this much volume of the the body will displace some volume of fluid. Please understand, some volume of liquid or fluid. This volume will also have a weight. Do you agree or not? In other way to say, how to analyze it? Fill a bucket fully with water and dip this duster halfway into the bucket and collect the water that is coming outside. Measure that water, that is the weight of the volume displaced by this duster. Do you understand it or shall I tell it once again? हिंदी में सुनो पहले हिंदी में समझो. एक बकेट लो, पूरा पानी से भर दो और इस डस्टर को डुबोना शुरू करो. पानी बाहर गिरेगा, वो सब पानी कलेक्ट करते जाओ, कहीं बाहर नहीं गिरना चाहिए, इतना डुबा दो डस्टर को. So some amount of water will be collected outside. उस पानी को वजन करो. That's a weight. Weight means a force. उसका weight जो होगा ना, वही buoyant force होगा. फिर से समझते हैं. अच्छा, हमारे जहाज को तैरते रहने के लिए क्या चाहिए? buoyant force चाहिए भाई. किसी भी हाल में buoyant force में कमी नहीं आना चाहिए. Remember that in mind. We have to keep the ship floating. Buoyant force में कमी नहीं आना चाहिए. Buoyant force should be there. तो the next question comes, sir, buoyant force होता क्या है? चलो उसको समझते हैं. When an object is submerged partially into a fluid or say water, this submerged portion will displace some volume of water. That displaced volume will have some weight in it. Do you agree or not? Some weight in it. that weight is equal to the buoyant force. So question comes, I want more and more buoyant force. So how should I increase? I should devise a floating article such that it displaces more and more of water. जितना water displace करेगा उतना ही buoyant force ज़्यादा. Now go to Wikipedia next time after this class and type RMS Titanic. So they will tell you manufactured at Belfast, Ireland, and so and so. Displacement volume they'll give you. Any ship, you take INS, Rana, Ranjit, Indian Navy के ships ले लो, all frigate class ships, R class, destroyers, they'll all give you displacement volume. वो जो carrier जानते हो, you know what's a carrier? Carrier is like India has got Vikramaditya, Vikrant और ये सब नहीं है, वो सब Vikramaditya means where aircraft can land. If you, how many of you have seen Pearl Harbor? अच्छा हाँ, उसमें देखते हो ना USS लिंकन जिसको वो जापानीज ऐसे देख ड्राम करके उड़ाता है. Those are all called carriers. Carriers have huge displacement volume. Huge displacement volume. जब जहाज को पानी में उतारता है ना, पानी फचाक से छोड़ेगा ना, this displacement volume. अभी जितना जो बाहर निकलता है. This is some coordinate of Atlantic Ocean. I have landed a ship out here. Don't you think water will be displaced from here? That is called displacement volume. That displacement volume's weight is actually the buoyant force. Okay, once again, ask me n number of times, don't hesitate, because you have to get the pleasure of this discussion. I fill a bucket completely with water. If I just touch the tip of the bucket now with my finger inside, some water will spill out, right? Because they have to accommodate the volume of my finger. So some volume of water has to come out. Now I'm putting this duster inside the bucket. What will you observe? Water getting spilled out. So मैंने यहाँ तक, I did it till here, till this level I have submerged it. Some water have come out. Do you first agree or not that the volume of this much portion of duster should be equal to volume of the water that has been spilled out? Agreed. That's what we did in this aloo example. Collect that water somewhere and find the weight of that water. That's the weight of the displaced volume of fluid. So I'll tell you. So the buoyant force is equal to that weight. Weight is a force. Do you agree? Weight is a force. That much force of. Now my question is, okay, let us go. As of now, imagine buoyant force is equal to weight of the displaced portion. I'll give you one more example. Okay, let's understand this way. Now, say suppose, have you gone inside a swimming pool? Say you are up till waist below the swimming pool. Don't you feel yourself as lighter? And when you come out, it's a big walk. Difficult hota hai na? So that means what? You are losing weight. You can't lose mass. Mass is constant across the universe. You're losing weight. Okay, this is your hand, and I have put a punishment to you. I have put a load of 25 kg on your hand. Your hand pains. Some good helper comes and gives you a force on this side. थोड़ा उठा दिया तुमको. You get relief or not?
Yeah.
You'll get relief. Suppose this fellow has given you what 20 kg का Newton force ऊपर दे दिया आपको. You now are bearing only how much? 5 Newton. So imagine yourself in water. ये legs हैं. हम पानी में चले गए हैं. Why has our weight reduced?
Because the upthrust is.
Some force is nullifying the weight of us. What is that force? Buoyant force. How do we say it equal? That will always be equal to one thing. This is the volume of your leg. The volume of leg. The volume of leg will always be equal to the volume of the liquid that you will be displacing. This volume of liquid will also have a weight. Not your weight. Will have a weight. This weight is nothing but a force. Agreed? This force acts upwards. That's why this much portion of leg was actually contributing some weight W dash. This force has nullified this W dash.
Oh,
It cancels out. But your overall body weight is W. And now you are weighing how much? W minus W dash. ये बाकी W dash कहाँ गया? ये भाई साहब ने काट दिया आपका. Have you understood? Buoyancy's discussion is spread on 3-4 sides. First, we understood what is buoyancy. We understood what is buoyant force. Then we need to understand how does the buoyant force help me? There is, first of all, when anything is submerged, its weight is felt less. Oh, weight कैसे less हो गया? Okay, I remember. Weight less कैसे हो गया? Less नहीं हुआ. We punished Zoe with 25 kg, 25 newtons. But still she is smiling. Did we reduce the force? No. Somebody is helping her from नीचे से. So where did the weight of your leg go? Somebody is actually cancelling that much portion. So overall body weight has come down now. Are you agreeing? But it depends upon, now Zoe, the next question should be like this. See, suppose I have, where I am submerging it only up to this much portion. This much portion will also displace this much volume of liquid. So buoyant force will also be less.
So the more you submerge.
The more you submerge, yes, you got it. The more you submerge, the more is the buoyant force. घुसाओ ना, हाथ नीचे घुसाओ पानी में, जितना घुसाओगे उतना बाहर आता है पानी. More is the buoyant force. पूरा घुसा दिया. Now buoyant force quota is over. Now no more there will be buoyant force. Whatever buoyant force had to be given, you have exhausted it. Because buoyant force depends upon how much you are submerging. Now you have submerged it fully. Quota pura complete. Quota pura complete. Titanic case. Ab is the max. So that night, if buoyant force would have been more on April 14, 1912, शायद हम बचते. नहीं हुआ. वेट ज्यादा था. तो हम नीचे चले गए. And you will go very fast with an acceleration. You will go force है ना. So have you understood one thing? Buoyant force now depends upon what? Buoyant force depends upon, you can write down, the buoyant force depends upon, after that you read your book, everything will be clear. The buoyant force depends upon the volume of the body that is submerged. Volume of the body that is submerged. और कोई नया चीज नहीं बता रहा हूं. टेक अ कोका कोला बॉटल, थोड़ा सा डुबाओगे थोड़ा सा झटका, ज्यादा डुबाओगे ज्यादा झटका, पूरा डुबाने के बाद भी झटका है और इंक्रीज नहीं होगा. मैक्सिमम आ गया है. ठीक है, जितना डुबोएंगे उतना झटका. राइट? ओके. So we're still in this part. That where the weight is more than the buoyant force. So you're sinking right now, right? What is the buoyant force equal to? Can you tell me? Buoyant force is equal to weight of volume of liquid displaced. Agreed? What is the weight of that volume of liquid displaced? There should have been. Now how to find out the weight? The weight is given by the mass of that volume multiplied by the density of the liquid. Mass into density of the liquid. I'll write all this again. I just don't want to lose the flow. Mass into density of the liquid. How do you find the mass? Our main equation, density equal to mass by volume. So we want mass. So we will say, mass in, yeah, weight of the volume. So weight is equal to, weight is equal to mass into acceleration due to gravity of that particular fluid, right? What is the mass equal to? The mass should be equal to density of the fluid into volume of the fluid into G, right? So I am saying that my W was greater than U. This is the entire calculation of U. Do you agree? Let's do the calculation of W. पूरा नीचे चला गया ना. So what is your W? Your W must be equal to your mass into G, mass of the body. What is the mass of the body? The volume of the body into density of the body into G. Don't you think volume of the body is same as volume of the fluid? Yes. By the आलू example, whatever आप डूब गए ना, तो ये दोनों को काट सकते हैं कि नहीं? The same. G को काट सकते हैं कि नहीं? और आ गए हम उस दिन के डिस्कशन में that if you sink your density is more than the density of the fluid. Come on, I'll write it again but get the pleasure of physics. Didn't we discuss that day कि डूबने के लिए तुम्हारा डेंसिटी ज्यादा होना चाहिए, आ गया ना तुम्हारा डेंसिटी ज्यादा. Let's do it once again cleanly. मिला इसको, चलो 1 minute थोड़ा भावुक हो जाता हूँ ये सब बढ़ाने में, क्या चलो. The case of sinking जाए क्लास में क्लास लो. Sinking means body completely submerged. Do you agree? Body completely submerged. Step number 1. Step number 2 means weight is greater than buoyant force. That's why you have gone down. So diagram will be something like this. Water is here and body is here. This is our weight and this is our buoyant force U and this is weight W and we are saying weight is. ठीक है सानवी, if you have any issue do tell me, beta, I'm not checking on you. Weight is greater than buoyant force. Do you agree? Right. Let us keep the greater sign just the way it is and let us solve the buoyant force. What is buoyant force? Buoyant force is weight of volume of fluid displaced. What does this mean? When I put something in, this is that alu's volume. When I put something in water, splash, water will gush out. वो पानी का weight of the volume. What do you mean by weight? Mass of, and let's say this volume of fluid displaced is VF. ठीक है, इसको VF मान लिया. Mass of VF. Weight means mass of VF multiplied by G. Do you agree?
Yeah.
Mass means density of fluid into volume, mass of that volume. So volume VF into G. Did you understand this part? Check, just keep checking, don't write blindly. Yeah, it's everything is happening. See, buoyant force has nothing to do with your body. Buoyant force, ab socho na, you went and jumped into a dry well. Do you expect buoyant force to help you? No. Buoyant force will always come from a fluid. That's why on this side everything is fluid. Buoyant force is weight of volume of fluid displaced. And what is that weight? Mass of that volume, not mass of VF. I'm putting an English word called mass of that volume into G. How do you connect mass? Remember this expression always. Yeah. Okay, let's see. How do you connect mass? We connect mass by the simple density is equal to mass upon volume. This is density. समझ में आया? So you don't have to find out mass. इसका ये इक्वेशन ले ले रे बाबा. अयो. Mass equal to rho v. इधर इक्वल डालो. What do you want to find out? Mass. Cover mass. Cover mass. Rho into v. What do you want to find out? Density. Cover density. Mass by volume. What do you want to find out? Volume. Cover volume. Mass upon density. Okay. Simple formula. Anything which is a ratio can be put like this. Simple, yeah. ठीक है? So density of the fluid into volume of the fluid. What is the density of the fluid? Sir, we will say, let's say we introduce a new Greek word here called sigma. Sigma is the density of fluid. This is called sigma. सीखो यार ये सब. कब सीखोगे नहीं तो? Sigma. So sigma in statistics is written like this. This is capital sigma. Small sigma is written like this. It's just like this. थोड़ा सा 6 को लिख के तो यूं ट्विस्ट कर दो. कैसा ट्विस्ट करेंगे? ऐसा. This is sigma, right? So sigma is the density of the fluid into volume of the fluid. So volume of the fluid is VF into G. Understood this much? बच्चा समझ में आया? अब चलो इस साइड करते हैं. Weight of the body. Weight of the body is what? Mass of the body into G. What is the mass of the body? Volume of the body into Rho is the density of the body into G. Agreed? Volume of the body. Now the body, which is our body तो पूरा पानी में चला गया, means entire volume of the body. You got a drowned case ना, पूरा volume है अभी. So we'll write volume of the body is written as VB. Don't you think VB should be equal to VF? That is the basic of any submerged case. Whatever volume body goes down, same volume of fluid comes out. तो इस बार हमने यहाँ पे VB और नहीं लिखा, VF लिख दिया, ठीक है ना, और रो को रो रख लिया और जी को जी रख लिया. देवा रे देवा, देखो बम्बई स्टाइल में प्रॉब्लम करेंगे अभी. अब क्या आएगा, अब VF को काट लेता, ये इसको काट लेता. ओहो, you're too excited जयदीप दास. It's like this. इसको काटो. ये सब पढ़ा के अच्छा लगता है ना, this is pure mechanics. आ जाओ. Rho is greater than this. Density of body is greater than density of fluid. Therefore, तुम्हारा डूबना निश्चित है. आदित्य समझ में आया? बोलो वानिया, ये चीज समझ में आया? And what was the condition we said for you to float? Density should be less. और एकदम लेवल में डूब जाने का, नीचे भी नहीं जाएंगे, ऊपर भी नहीं जाएंगे. What is the case there? Density should be equal. अभी उसमें आएंगे. और ऐसे डायग्राम में पानी नीचे चला गया. मजा आया? आ जाओ. अब हम क्या करेंगे? Now we will say, अब थोड़ा गोवा जैसा फीलिंग लेंगे. You know, I'm just sunbathing and getting tanned. You know, अब गोवा वाला फीलिंग लेंगे. गोवा फीलिंग is something like this. विवान सोच रहा है गोवा बोलते ही अभी एकदम फिश फ्राई पोर्टुगीज गाने बचेंगे, ठीक है. गोवा फीलिंग मतलब आप बिल्कुल यहां हो, पानी के सतह पे, कुछ तो बात है कि मैं डूबता नहीं हूं. जस्ट दिस इज कॉल्ड जस्ट सबमर्ज्ड. यू कैन टच, टेंजेंट जैसा है पानी ऑन यू. इसका मतलब क्या है? W, तू और मैं बराबर है. Weight is equal to the buoyant force. Buoyant force is giving him the last warning now. बाबू, इसके बाद अगर तुम एक कैडबरीज भी डालोगे ना, तुम डूबोगे. Will go down. Buoyant force is like your conscience. You know, Jaideep Das keeps on saying study. So your conscience will say, सार्थक फुटबॉल मत खेलो, पढ़ो. सार्थक कहता है छोड़ो, मैं तो फुटबॉल ही खेलूंगा. पहले वो मूवीज में दिखाता ना, you go to brush your teeth and then on the mirror it comes, ये सार्थक, you should study now. प्रतिची, लेसन को पढ़ो, ऐसे करके बोलता होगा. लेकिन प्रतिची तभी कहता है फट ऐसे चला जाता है. तो नाउ अभी प्रतिची उसके सामने जितना भी ब्रश करो निकलता ही नहीं है वो कॉन्शियस लिसन्स टू यू टू अ लेवल. ठीक है, तो इसका इक्वेशन देख लेते हैं. नाउ W शुड बी इक्वल टू U. अगर ये सब कहानी करेंगे तो क्या आ जाएगा? Rho शुड बी इक्वल टू सिग्मा. सेम कहानी ना, ओनली बाबा रिप्लेस दिस साइन बाय ए इक्वल टू. कहानी रिमेन्स द सेम. अग्रीड? आप करके देख लो, आपको मजा आना चाहिए. खाली रट लिया. What is buoyancy? Buoyancy is the phenomenon due to which an object when submerged fully or partially experiences an upward force.
So in this body will partly be submerged.
नहीं, ये पार्टली नहीं, पूरा सबमर्ज्ड है, जाएगा नहीं नीचे. It's like this. तैर रहा है जस्ट ऊपर. It's not going down. थोड़ा भी नीचे अगर गया ना तो पूरा चला जाएगा. It's just at the level. This is seen generally like plank of plywood फेंक दो पानी में. रिवर वगैरह में जब शिपरेक होता है ना, तुम लोग तो मूवी क्या देखते हो भगवान जाने. शिपरेक मूवीज नहीं देखते हो? अच्छा वो देखते हो, जैक एंड द पायरेट्स देखते थे? तो जैक एंड द पायरेट्स, नेवरलैंड पायरेट्स आता था ना. हाँ, जैक एंड द नेवर, सबका स्टोरी है. देयर इज समथिंग, पायरेट्स इन द कैरिबियन, वो तोता आता था ना, जैक एंड द नेवरलैंड पायरेट्स. तो उसमें जैसे ऐसे पकड़ के तैर के आ जाता है ना, बिकॉज़ प्लाईवुड विल, you best example is you have those decathlon floating mats you get, right? Flaps आता है ना, उसको पानी में छोड़ दो, वो जस्ट डूब के ऐसा पड़ा है. वही केस है ये. उसको थोड़ा भारी करो, थोड़ा, वो एकदम ऊपर रहता है, उसको थोड़ा भारी करो, नीचे चला जाएगा. टोमेटो केचप थोड़ा सा इंजेक्ट कर दो. अच्छा, नेक्स्ट केस इज, our last case is our body will be completely on top, disco dancing. Now here W and here U. यहाँ U का पूरा दादागिरी है. U is fully in dadagiri. But the question arises, sir, you told when a body is partially submerged or fully, आपने तो submerge ही नहीं किया, थोड़ा डुबाना पड़ेगा, नहीं तो U नहीं आएगा. ऐसे U थोड़ी आ रहा है ना, U डूबने पे आएगा, थोड़ा डुबा दो, थोड़ा डुबा दिया. This much portion is inside water. And how much light will this block feel? Zoe, your question. How much light will this block feel? This block will feel as if this portion has been cut off from the block. When you go till your legs inside, you feel your legs have been amputed. I should not say like that. As if legs have been amputed, your body is without the legs. Because that much portion has been taken care by Pebble City's maintenance that my dad pays. Swimming pool water. ठीक है ना? चलो, तो इस केस में हमारा क्या होगा? W ये फ्लोट कर रहा है, तो W must be less than U. U must be winning the battle. इसको सॉल्व करेंगे तो क्या आएगा? समझ में आया? अब आओ जहाज के बारे में. ये जहाज है और ये शिप में भी ना पानी यहां तक तो रहता है, पूरा शिप थोड़ी ऊपर फ्लोट करता है, नहीं तो उसको इक्विलिब्रियम नहीं मिलेगा ना, शिप गिर जाएगा ऐसे. यहाँ पे शिप्स में देखना कभी भी मूवीज में लाइंस रहते हैं, इनको बोलते हैं प्लिम्सन लाइंस, प्लिम्सॉल लाइंस, PLIMSOL. Plimson lines are for the captain to see how much you should load the ship. If you are actually loading it too much on this Plimson line, tells you कितना ship पानी के अंदर गया. ये रहता है. This indication will always be there, and they should not be loaded beyond a certain point. Now our question arises, 3 questions. Why does ice float on water? A very beautiful example. Okay, ये सब कहानी समझ में आ गया. अब कुछ फ्लोटेशन के केसेस देखते हैं. Can I? You had some question. Yeah. Can I rub this one? Okay. Let's take the simple case. Our Vivan darling wants to have some orange squash, and it's water. Orange squash density will not be exactly water, but imagine there is water. He loves chilled water. So this is Vivan's glass of water, and our friend loves to have with ice. And the ice is not dry ice. The same water his mom had frozen. And you will find that ice will always float in such a way that 1/10 of the ice will be just above. Baki ice niche jayega. That's the main reason is the density of water is 1000 kg per meter cube and the density of ice is 990 kg per meter cube. कौन हल्का? Who is lighter? Ice. But एकदम बराबर, इसलिए 1/10 ऊपर रहता है. And if you are substantially light, like he's having a mango shake whose density will be very high, and I ensure that I put a housefly on his mango shake, so the housefly will be floating. मरेगा नहीं. मक्खी चूस है तो उसको चूस के फेंक लेगा, उतना सा लॉस हो रहा है ना. You have to have that much of mango juice also. इसीलिए तो monkey juice dialogue बोलते हैं ना. What does monkey juice means? दूध में जो मक्खी गिरा उसको भी then throw the मक्खी. हाँ. What is great? तुम लोग हॉस्टल में कैसे जाओगे फिर? Hostel means your life is what do I have to do with he is doing? करने दो. The best of the kachori shops and the golgappa shops can never be in clean places. There has to be a public bus stand and all. Then you see kachori is very tasty. Until the person does not sweat and make kachori, the kachori cannot be tasty. और हाथ में आजकल gloves रहता है. Ma'am, इमली पानी for you. ऐसे देते हैं क्या? Shall I put some चाट मसाला? वो ऐसे, हाँ साहब बोलिए, हाँ पैसा रख दीजिए वहाँ पे. हाँ बोलिए आपका कितना चाट है लीजिए, ऐसे करके दीजिए. हाँ ठीक है, उसी में टेस्ट आता है. तो हाँ ठीक है, चले हो गया. इसलिए इम्यूनिटी नहीं है तुम लोगों में. हम लोगों ने कभी स्कूल में हैंड वॉश किया है, जाना ही नहीं, जो दिया वही खाया. ठीक है, चलो हो गया. ये समझ में आया. आइस का केस समझ में आया. अब आते हैं शिप के केस में. Now next question is about ships. Why do ships float? So what happens in case of ship? As I told you, the bottom of the ship is hollow. Ship takes in lot of air. Air जाने से कोई भी चीज हल्का हो जाता है, मास नहीं है. And ship, one is hollow. Shape is given in such a way when you lower. Have you seen in YouTube ships being lowered into water?
Yes.
कितना पानी splash करके फेंकता है, देखियो. That is volume of fluid displaced. The more and more volume of fluid you displace, today you go to YouTube and do something. Titanic, Louisiana, Olympic, ये सब जहाज हैं. बिस्मार्क, सब डूब के अटलांटिक के नीचे है. You just go and see their displacement volume. ये वॉल्यूम रहेगा. The more you displace, buoyant force चाहिए ना. Buoyant force आएगा कहाँ से? Weight of the volume of the fluid displaced. Got it? So ships are able to. Submarine is very interesting. Submarine is somebody who can as his wish go down and go up. So submarine is done in such a way that it is a floating ship, but it has got watertight compartments. They open their water compartments and water gets inside. It is just same like विवान को लेके मुंह में पानी पिला के स्विमिंग पूल में छोड़ो, the submarine goes inside. And what does the submarine do to come up? Comes up. Now comes the next question. Between human beings density is actually little bit lighter than water, just little bit lighter than water. ठीक है, थोड़ा सा lighter है. ऐसे आप बोलोगे कि सर मैं तो डूब गया, तो कारण बताता हूँ भी. Human beings density. अच्छा, before that, tell me, sea water and normal water, भारी कौन सा होगा?
Sea water.
Why?
Because
Salt. So whose density is more?
sea water.
So where should we be finding it easy to swim? So because sea water, why is the volume of your response come down now? That shows lack of surety in your response. I asked which is more heavy, your volume was this. Which has more density, your volume was this. My next question was, where should you be able to swim more? More density means density ज़्यादा है रे बाबा. If the density is more, the buoyant force will be more. So you should be, it's not that you will be easy to swim on sea water as compared to river water. Okay. Now let us take the case of human beings. Human beings densities are little bit less than water. So what happens when you go to a swimming pool, knowingly or unknowingly you will gulp water. So let's see the case of death. When a person dies, water, किसी को पानी में छोड़ दिया ना, तो हिंदी मूवीज में आप सीन देखोगे, बक 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 करता है ना मुंह में, आज तुझे नहीं छोड़ूंगा पानी नीचे, then he'll do chappat chappat chappat, then suddenly hands become like this, and blub 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 blub, bubbles will come out. That means he drank that much of water, पानी मुंह में चला गया. And then after death, the body will first come down. First the body will come down. Always it will go down. Once the body goes down, after that what happens? Microbes starts their action on your body. ये forensic science में भी पढ़ाते हैं. These microbes will start. आपका body मर गया ना, so the anaerobic bacteria which do not need oxygen, पढ़ा है ना biology में, anaerobic respiration process starts, and your fat is slightly lighter than water in density. So all these microbes and fungi will start working on your body, and they will put lot of gas inside you. आपके lungs के अंदर और इसमें methane and other gases will be. जैसे ही ये गैस आ गया, इसको बोलते हैं ना मरा हुआ आदमी का पेट फूल गया है, bloat आ जाएगा, and then the body will come up. It will take time when the body will come up. If you throw a dead body into cold water, the body will come up after a long time, because in cold water, microbe action is not so faster. But if you throw somebody in the water of Nigeria, जहाँ पे बहुत गर्मी है, oh, there is a dead man here coming up. That man will come up in 2 days, not more than that. And in forensic, they say that looking at the time in which the body is floating gives you an indirect way when the death happened. इसको putrefaction बोलते हैं, PUTREFACTION. Post-mortem means after death. So after death, microbes start acting, gas starts filling in your body, and the body starts coming up. Have you understood now? The body goes down because the body has drank water. After that, what will happen? Your death. Now microbes will start working on your body, and they will induce lot of gases in your body. पेट फूल के आता है जब कोई आदमी पानी से आएगा, गैस घुस गया आपके बॉडी में. Now comes, sir, you are still slim. How about that whale that it just comes out so cutely and goes inside? So whales have got something in their body called swim bladder. Swim bladder is a portion जहाँ पानी भी ले सकता है, हवा भी ले सकता है. जब whale को इच्छा होता है ना, I need to go and see how Pebble City is. It comes out, so it gushes lot of water inside. That's why when you go for dubki inside na, if you drink water and go inside, you'll go inside. Your mouth cannot go below the water. If you want to learn swimming, simple thing, mouth above water, mouth above water. Mouth नीचे गया, आप डूबोगे. केस समझ में आया? और लास्ट चीज, अभी भी टाइम है, इतना चीज समझ में आया, what is buoyancy and how you float. Now can you explain anybody how you float? The last thing, and then we'll do a recap. Now we go to what is Archimedis principle. You have actually already studied Archimedis principle. Archimedes one day, actually in those BC period, he went there and splashed himself into a bathtub, and then he felt water came out. So Archimedes principle says that the weight of the body submerged in a fluid is always equal to weight of the volume of the fluid displaced by the submerged portion. Maybe I am talking too much. लिख के दिखाएंगे तो 1 मिनट में समझ में आएगा. देखते हैं आर्किमिडीज प्रिंसिपल क्या कहता है. ये तो आप अभी तक समझ गए हो. Have you understood that the leg वाला एग्जांपल याद है? जितना लेग अंदर जाएगा उतना ही पानी बाहर आएगा. So Archimedes principle says that the weight of, exactly the same example I gave Zoe. Zoe, you feel your body is lighter and does not have the legs. That means weight of the submerged portion of the body. If you don't understand, then relate to the legs wala example of Zoe. This is the legs. Weight of the submerged portion of the body is equal to weight of volume of fluid displaced. Displaced by whom? Displaced by this leg, by the submerged portion of the body. Now see Zoe, it will be so easy. What have I written here? Weight. Is it not a force? Is it not a force? If these two are equal, that's why you feel your leg is not there inside the water. Yeah, weight of the submerged portion of the body. And Archimedes became so happy that without clothes he ran up from the bathtub. And he wrote the word Eureka, Eureka. I have found it, I have found it. उस जमाने में मोबाइल नहीं था, नहीं तो MMS बन जाता आज फिर. Archimedes का मोबाइल MMS. That's the secret of happiness, na my dear. Just like after watching Jawan movie, you forget that there is a nice teacher Jaideep whose class should be attended. You haven't forgotten that. The ecstasy of achievement is such. So he has forgotten. Hey, कभी चुप करो, वो रो देगा बाद में, वो सबमर्ज हो जाएगा नीचे. He has gone for a 6:45 movie. Even before the sweepers of the shopping the mall reached, he reached. ये सब शाहरुख खान, ये सब all these he creates. He will hype up the distributors, open your theater at 6:45, rush दिखाओ लोगों को, and there are a lot of people also. Right? Archimedes principle. This is Archimedes principle. Archimedes, Archimedis. It's a proper noun. Archimedes. Archimedes. ARCHI or CHEI लिखते हैं बहुत. CHIMEDIS. Archimedes. Archimedes principle states that when a body is submerged in a fluid, आप और सुंदर से लिख सकता है. When a body is submerged in a fluid, weight of the submerged portion of the body, that is the legs, are equal, or the alu is equal to weight of the volume, वो जो बाहर लेके वजन किया था, of the displaced portion. हमेशा याद रखो. तो अभी हमें क्या करना पड़ेगा? हमें अगर हम जहाज डिजाइन कर रहे हैं, जितना जहाज पानी के अंदर गया, ठीक है, उसका जो वेट है विल बी इक्वल टू जितना जहाज पानी डिस्प्लेस करेगा उस पानी के वेट के साथ. नाउ इफ यू वांट टू इंक्रीज दिस पानी, यू हैव टू इंक्रीज दिस. लेकिन इसको ज्यादा डुबा नहीं सकते ना, जहाज है. तो वेट को कैसे बढ़ाते हैं? जस्ट सोचो, कॉमन सेंस लगाओ. वेट का फॉर्मूला फिर से देखो, मास इनटू ग्रेविटी. नाउ वी वांट द जहाज टू डिस्प्लेस मोर एंड मोर लिक्विड. That is equal to weight of the submerged portion of the जहाज. But जहाज cannot go too much down. हमको जहाज का वेट बढ़ाना है, लेकिन डूबना भी नहीं है. Weight is mass into gravity. Mass is equal to density of the metal जिससे आपने जहाज बनाया है, into volume of the जहाज. That is mass into gravity. क्या इस पे आपका कंट्रोल है? नहीं. क्या इस पे आपका कंट्रोल है? नहीं. Density of a metal you cannot change. कुछ भी idiotic answer. Why your volumes come down when you answer such questions? It actually gives me pain. You may scare whatever in your test, but when you answer these questions slowly, I still feel तुम समझे नहीं हो. G को कंट्रोल कर सकते हैं? नहीं ना. Density of metal you can't. Density of iron is density of iron. Whether it is a nail, whether it is a bolt, whether it is an arrow, whether it is a clip, whether it is whatever it is. इसको चेंज कर सकते हैं? नहीं. अब इसको बढ़ाने का एक ही रास्ता क्या है? घटोत्कच की तरह अपनी काया बढ़ाओ. Make the ship as large as possible. Now let us see why does an iron nail sink. अब आयरन नेल को डुबा देंगे. आयरन नेल के डेंसिटी पे आप कंट्रोल है, जी पे कंट्रोल है, और गधे की तरह तुमने उसका वॉल्यूम एकदम स्मॉल लिखा है. नेल्स वॉल्यूम इज वेरी स्मॉल, दैट्स व्हाई 1000 नेल्स आई कैन नोबडी सिंक मी, ऐसे लेके मैं जा सकता हूँ. वॉल्यूम कम है ना. क्या फेदर डूबता है? उतना फेदर लेने के लिए मुझे कैसे जाना पड़ेगा? रोमियो नाम मेरा, लाइक सांता क्लॉज, लॉट ऑफ वॉल्यूम. डोंट यू एग्री? इसलिए फेदर डूबता नहीं है. मार मार के इतना फ्लैट करो कि यहां से मेन गेट तक एक पतरा बन जाए, डेयरी मिल्क का फॉइल बन जाए. फिर डेयरी मिल्क फॉइल इज मेड अप ऑफ एल्यूमिनियम ना, फ्लोट करेगा ना वो. अगर और अच्छा देखना है तो आज जाके टॉयलेट सीट में एक टैबलेट का जो फॉइल होता है ना, ऐसे टॉयलेट टपक करने से पीछे से टैबलेट निकलता है ना, वो जो गोलू क्रोसिन. नेक्स्ट टाइम यू हैव अ डोलो and you punch out the dolo, there will be a golu foil coming out of the dolo. Take the foil and put it in your toilet and observe it floating. You will in your life never forget what is buoyant force. And in order to sink it, what you will do? You will flush it. So you are putting external force. So net force means now it will go with acceleration. शैच करके चला जाएगा. तब तक शायद ये STP चला जा चुका है. I love science. Have you understood? And that concludes the chapter of gravitation and flotation. Should there be any question, I'll be happy to take. But you know, your friends in CBSE, they do a lot of problems on this. We still did not discuss many things, relative density. But as of now, as you go out from this class, you should know, I float when my density is less than the density of the fluid. But then a nice man will tell you, do you have control on the density of iron? No. Do you have control on the density of water? No. I have control on this V and this V. इसको बड़ा करो. अपनी काया बढ़ा पुत्र और शत्रु सेना पे गिर. That's like Ghatotkaч. Oh, Ghatotkaч, you know, he's that cool dude who was the son of Bhim, and he sacrificed his life because he increased his body, because Karn was having a special arrow kept for Arjun, and they had to save Arjun, so they needed that arrow to be neutralized. So Abhimanyu was the son of Arjun. All the sons died in this battle. Bhim's son is Ghatotkaч when Bhim married the demon princess Hirimba. Alright. You should know this, you should know that. नहीं ये इतना जान लिया. Right, kids?